So in this lesson, we are going to look at heat. So the first thing we need to understand in relation to heat is that heat is a form of energy. Okay, so if we remember, everything in the world is made up of two things. We have matter and we have energy. So we have matter and then we have energy then as well. So we have these two parts. We have like matter and energy. And matter is made up of atoms, and it has space. It occupies space, and it has mass. And energy then basically it has the ability to make matter do work, or it has the ability to change matter in physical ways. Okay, and this is ways that matter can be changed or rearranged is what are known as the states of matter. And the states of matter, we have the three main states, and there's another state as well, but you don't need to know for your juniors. So things can exist as solids, liquids, or gases. And then if we take energy in the form of heat, for example, so if we take heat energy, so heat energy, basically we can use heat energy, and if we add it, for example, to a solid, what will happen is if we add enough heat energy, it'll melt and turn into a liquid. And then if we add some more, keep adding heat energy, it'll vaporize and turn into a gas. And then if we take that gas and we take away heat energy, we cool it down, it condenses into a liquid. And if we continue to take away heat energy, it'll freeze back into a solid. So heat as a form of energy has an impact on matter. And basically when you start adding heat, for example, to a solid, the solid starts to expand and the atoms that make up the solid start to move away from each other. And the same with a liquid and the same with a gas as well. And we'll have a look at this in a simulation now. So if we have a look at this simulation, so what we have here, we have a solid, okay? So what we can see is the solid is made up of individual atoms and they're all bound closely together. Now you can see that they're still moving and vibrating, but they are in a solid form. And we can see that the temperature is very low, it's minus 259 degrees. So in this state, these particular atoms stay as a solid. Now what we can do is if we start adding in heat, so we start adding in heat, what will happen is each of the individual atoms will start to get energy and they'll start to expand. Okay, so what we can see is it's turning into a liquid and then it's very quickly turning into a gas. Okay, and that's by adding heat, for example, and heating up the substance. So when we add heat, the substance will expand until it turns into a liquid and then it'll turn into a gas. So if we have a look, so a material that's in a solid form, its particles will be arranged like this. Then if we add heat, it'll turn into a liquid form and its particles are kind of arranged like this. Okay, they're not as tightly bound to each other and they have more room to move around. And then if we keep adding heat energy, what will happen is they will completely expand away from each other and it'll be like this. Okay, so the particles will be moving around freely. And then if we start to take away the energy, okay, so we start to cool down this system, it'll turn back into a liquid. And then if we continue to take heat energy away, it'll turn then back into a solid. Okay, so that's what we mean when we talk about states of matter. And heat has this ability to cause the atoms to move away from each other. Now, another thing to think about as well is if you think about the amount of energy then the system has. So when a solid is like this, it has a certain amount of energy. But if we add heat energy to it and we turn it into a gas, so all of a sudden you have these particles that are flying around everywhere. And these particles, because they're moving, they carry kinetic energy or movement energy. And when they collide with an object, they transfer that kinetic energy into the object. So if we create steam, for example, we can funnel that steam to turn, for example, a turbine or turn a piston. And what will happen is that it'll do work. So we can use steam, for example, in steam engines to get them to move like huge loads of mass by using the kinetic energy that comes from the movement of the individual particles that make up the substance when it's turned into gas. So again, we can have these states of matter, and we can change between these states of matters by adding heat or taking heat away, for example. So how can we say that heat is a form of energy? The evidence that heat is a form of energy is that heat can cause movement. So for example, if we think of a steam engine pulling trains, okay, that's where you're taking heat energy and it's being converted into kinetic energy or movement energy. Curtains moving when they are above a hot radiator. So for example, if you have a radiator, let's say you have a radiator here like this, and the radiator is turned on, what's going to happen is you will get these like convection currents. Okay, so that the heat will actually move up like this, and then if you have curtains, then for example the curtains will be here, and what's actually happening is the particles of air are hitting against the curtains and they're causing the curtains to move around. Okay, so again, that's another, you're showing that energy is getting, the heat energy is causing the curtains, for example, to move. So again, this is a steam engine, and basically they don't really use steam engines anymore, but what this is doing is it's taking heat energy and it's turning it into movement energy or kinetic energy. So since heat is a form of energy, it is measured in joules. So we use the joules to measure heat. So we use joules to measure it. Okay, so heat is measured in joules. So as heat is a form of energy, it can be converted into other forms. For example, in power stations, oil and gas are burned to produce heat energy, and this heat produces steam, which turns the blades of a turbine, and it produces kinetic energy. This turning of the blade produces electrical energy as well. Okay, so we have this process of conservation of energy. Conservation of energy. So you have energy changing from one form into another. So for example, if we take a piece of coal, okay, and we burn it, okay, so we put it on fire and we burn it. So that is taking chemical energy, and I'll just abbreviate it as CE. So chemical energy. And that chemical energy is giving off heat. Okay, so it's turned into heat energy. That heat energy then has been used to make, for example, steam, okay, which is basically taking heat energy and turning it into kinetic energy. And then that steam is used to turn a turbine. So imagine this is a turbine. Okay, so the steam hits against the turbine, it causes it to rotate or turn. Okay, so again, that's taking this kinetic energy and turning it into another form of kinetic energy. And then that will move a piece of copper inside a magnet, and then that kinetic energy will be turned into electrical energy. Electrical energy. And then that electrical energy will be used by houses, and it'll be changed into loads of other different forms of energy. So essentially what you have is you start off with coal and you have chemical energy, and this can be any other heat source as well, or fuel. It could be oil either, and once you burn it, it starts to release heat energy, and that heat energy can be measured in joules. So we have this conservation of energy principle. So energy is basically being changed from one form into another. So how do we measure the temperature of a substance? Okay, so how do we measure temperature? So we use a thermometer to measure hotness or temperature. So for example, we can use an electrical thermometer like this. We can just put it in and basically it'll give us out a temperature reading. So if we think about temperature, so we measure temperature in degrees Celsius. Okay, and we can use one of these guys, which is a thermometer. So we can use electrical, so we have electrical thermometer, and then you can also have, for example, a lab thermometer as well that looks like this. So basically what will happen is, depending on the amount of heat energy that is absorbed by the top of the thermometer, that will determine, for example, how hot or how cold the substance is, and that will give us a reading in temperature, which would be in degrees Celsius. So heat is a form of energy, and temperature is a measure of the hotness of a body. Okay, so heat basically, heat is like heat is a form of energy, but heat causes hotness or coldness in an object. Okay, so the more heat you have, or the more heat that's applied to a substance, what happens is the molecules or atoms in the substance, they vibrate more. Okay, and the more that they vibrate, the more vibration there is, the more like hot or cold the substance is. So if it's vibrating a lot, it's going to have a high temperature. If it's not vibrating a lot, it's going to have a cold temperature. So in relation to heat energy, so what is meant by expanding and contracting? So heat causes expansion. So that's basically when things get bigger, and cooling causes contraction when things get smaller. So when we add heat, what we actually do is we cause the material that we're adding the heat to expand. It'll actually get bigger. And then if we take heat away, what will happen is the substance will actually start to cool down, and it will not expand as much. So if we have, let's say, so imagine this is a piece of metal here. Okay, so, and we add some heat to it. What's going to happen is you're going to get some contraction. So it's actually going to expand. Okay, and then if we take the heat away and we let it cool down, what will happen is it will contract back to its original size. So heat expands and contracts material all the time. So the Golden Gate Bridge in San Francisco changes length by over 1 meter between the winter and the summer due to expansion and contraction. So this is the Golden Bridge in San Francisco. So it's a huge massive metallic structure, and when that heats up in the summer, what's going to happen is you're going to get this, it's going to contract, and then during the winter time when it gets cold, it's going to expand as well. And also as well, what you might notice as well when you're walking around, if you look at any ESB pole, for example, and you have the wire, let's say, that's expanding from one pole to the other, in the winter time it'll be like this, okay? And then in the summertime when it's hot, it'll expand and it'll actually droop down like this as well. So you get this contraction and expansion. And also another thing as well to notice, if when you're walking home, have a look at the path that you're walking on. What will happen, what you might notice is that the path is put into sections like this. Okay, so you have sections like so. So the concrete is poured in sections like this. Why is it poured like that? The reason is that when the heat from the sun shines on it, let's say during a hot day, what will happen is the concrete will expand. Okay, so it'll expand, and then when it cools down, let's say on a cold day, it will contract. Okay, so it'll move in and out. So if you don't put this kind of gap in between the pores of concrete, what will happen is you'll get a crack. You'll get a crack in the concrete, and that comes from contraction and expansion caused by heat energy. So the Eiffel Tower in Paris is 300 meters high and is made of iron. Between summer and winter, its height changes by as much as 7.5 centimeters. So again, an iron structure that will, when it's heated, it will contract, and when it's cooled down, when it's heated, it will expand, and when it's cooled down, it will contract. So it's very important for, if I'm an engineer, for example, and I'm building a bridge, or I'm laying a path, or I'm putting up electrical wiring, that I understand the effects that the temperature, that the heat, for example, that's in the environment is going to have on it. And you have to kind of account for that when you're building your structure. So for example, if they didn't do that with the Golden Gate Bridge in San Francisco, the bridge would collapse. So it would. And another kind of dramatic example of that is that if you have a sealed bottle or a can and it's put into a fire, what happens is it will explode. So if you take, let's say, an aerosol can like this, inside the aerosol can you have gas particles, and what happens is if you add heat, those gas particles, so if you add heat, those gas particles inside here will get a lot of energy, and what they'll do is they'll bang against the side of the container. So they are expanding, and they will expand and they'll keep expanding until basically until the container buckles, and then basically it'll explode and the gas particles will be able to get out. Okay, so again, that's another example of how when you heat a substance, be it a solid, a liquid, or a gas, it'll cause the substance to expand. So heat transfer then. So heat then is basically moved around, let's say, in an environment. So we want to look at the different ways in which heat actually moves around in an environment. So the first way is by conduction. So heat basically by conduction, what has to happen is so if I have, for example, let's say I have an object like this, and if one side of it is hot, imagine this is hot. What's going to happen is by conduction, because the atoms here at this side are in contact with the atoms on this side, what will happen is the heat will conduct or move through the substance. Okay, so when they physically come into contact, what happens is, think about, like, this is basically made up of atoms that are all vibrating, and when those atoms come into contact with the atoms here, they're going to cause them to vibrate, then it's going to cause the ones here to vibrate, and what you will get is you will get this conduction of heat. It'll actually move through the substance, like so. Another example of this is if you take, let's say if you have a pot and you are applying heat to it. Okay, so imagine you're applying heat and you put a spoon in it. Let's say you put a metal spoon inside it. What will happen is after a while, so imagine this is your substance here. What will happen is after a while, the heat by conduction, it'll vibrate up, right up through and then into your hand, for example. So this is what's called heat transferring by the process of conduction. So the way to kind of think about this is when a hot body comes into contact with a cold body, what happens is the heat is transferred through from the hot to the cold by the process of conduction. The next one is convection. Okay, so way to kind of, so conduction generally happens in solids. So conduction. Okay, so you have conduction and it generally happens in solids. So basically what's happening is the heat is, if you like, vibrating through from hot to cold. Then you have this next process, which is called convection. And the way to kind of think about convections is that it happens in liquids and gases. And essentially what happens is, so if you have, let's say this is a body of water. Imagine this is water. And when you add heat to the bottom, okay, so imagine you're heating this like that. What happens is the particles at the bottom start to get hot and they start to rise up. Okay, so they rise up to the top. And then when they get to the top, they start to cool. So then they start to fall back down again. Okay, and then the heat will give them more energy and then they'll rise back up again. Then they'll cool and then they'll fall back down again. So what's happening here is you're getting these things called convection currents. So convection currents. So what will happen is, so let's say this is like a liquid like water, you will get this heating effect. So you get this kind of like this body of water getting hot, it moves up to the top, and then what happens is it loses its heat, so it goes back down to the bottom, and it keeps moving around like this. So these are what are called convection currents, and it'll keep doing this until the whole the whole amount of the liquid is hot. The other thing as well is it can happen, exactly the same process happens in the air. So the same process happens in the air. So for example, if you have land here like this, and sun heats up the land, okay, so so imagine this is land, and it starts to get hot. Okay, so this is the land, and then this is the air. And what will happen is the air here at the bottom will start to get hot, and it'll move up, and then when it moves up, then it'll get up here, it'll start to cool down, and it'll start to fall back down again, and then it'll heat up, and it'll start to go up, and then it'll cool, and it'll start to come back down again. And again, what you do is you get these convection currents. And sometimes what you'll see if you look around in the summertime, particularly in a hot day, you might see birds, for example, and they're kind of just moving around like in a circle, like kind of circling around in a particular space. What they're actually doing is they're riding around on these convection currents. Okay, so basically the land gets hot, so the heat from the land, this corner here, so the heat from the land is transferred into the air. Okay, and then what happens is you get this movement of heat through the air through these convection currents, and this generally happens in a liquid. And then the last form then is what's known as radiation. So this is what happens, for example, with the sun, so radiation. So what will happen is so this generally, it doesn't need a medium like a solid or a liquid. So what will happen is if you take the sun, for example, and then in space you have a vacuum. So what happens is the sun radiates heat through the universe in the form of light, for example, and then that heat energy then will reach the earth, for example. So this is the sun, and then this is the earth, and that will then, like for example, it'll start to heat up. It'll start to heat up the earth. So that is radiation. So that is radiation. If I put that here, so radiation. So essentially, the heat is radiating out from the sun. So let's look at these. So conduction is the movement of heat energy from one object to another that is in direct contact and is at a lower temperature. So for example, heat moving from the hot water into the colder spoon, so it moves from hot to cold. Conduction works really well in solids such as metals. And then you have this example here. So a saucepan on a hot knob is heated by conduction. So the heat from the flame is being transferred into the water, and then it can be transferred, for example, up the handle. That's why they make the handles out of different materials. They're not as good conducting materials of heat. Convection then. So convection is the movement of heat energy within a liquid or a gas. So like what we've said here. Because particles within a liquid or a gas can move, they can transfer the heat within the liquid or gas. This occurs when warmer areas in the liquid or gas rise and are replaced by colder liquid or gas. So again, this region down here will be warmer because it's in contact with the heat source. The particles are free to move, so they'll move up to the top, then they'll cool, and then they'll move back down again. And essentially what you do is you get heat moving around in the substance. So for example, water is heated in a kettle by convection currents. Okay, so you get this convection currents that spreads the heat around in a kettle. And radiation then is the hotter an object is, the more heat that is emitted or released from the object. So no particles are needed to carry the heat. This form of heat energy, radiation, can move through a vacuum. A vacuum has no particles in it, like space in the solar system. So for example, when we talk about a vacuum, so for example, we're talking about a vacuum in space. So we have a vacuum, for example, in space. So all of this area here would all be a vacuum. So there are no particles in here. So therefore radiation can move by heat can move through radiation by radiation from the sun to the earth. So the next principle we want to look at then is this idea of what's meant by latent heat. So when you heat an object, you expect the temperature of the object to rise. However, this does not always happen, and if you look at the situation below. So for example, if you put a thermometer into ice and you add heat to the ice, what will happen is, even though there's heat being added, the temperature will not change until all the ice has melted. And then once the ice has melted, then what will happen is the temperature will start to increase. Okay, and then the temperature will increase up to a point, and then it will not increase anymore until it turns into steam. And then what happens is it turns into steam, and then the temperature starts to increase then as well. So when you heat a beaker of ice, the temperature does not rise until all the ice has melted. And when you heat a beaker of boiling water, the temperature does not change. So what do we mean by then latent heat? So when you slowly heat a beaker of ice, you will notice that the temperature does not rise at first. The temperature remains at 0 degrees for several minutes until the last piece of ice has melted. And when you heat a beaker of boiling water, you will notice that the temperature does not rise. The temperature remains at 100 degrees Celsius. So what happens to the heat energy? So heat energy cannot just disappear. So in the situation shown above, the heat changes the state of the ice, of the boiling water, and when heat changes the state instead of temperature, we call it latent heat. So what we can do is we can look at something like this. So if we take, for example, ice and we add heat to it, and we measure its temperature over a period of time. So what we'll notice is that the temperature will kind of stay constant, and then what it'll do is it'll jump up, okay, and then it'll stay constant for another period of time, and then it'll jump up. Okay, so from here to here, this is where we're going from a solid to a liquid. Okay, and then once we've turned into a liquid, the temperature will start to increase, and then from here, so from here to here, for example, we're going from a liquid to a gas. Okay, so from here to here, so the temperature will not change, and then then the temperature will jump up. So it will, okay, so we're going from a liquid, so solid to liquid, and then from liquid to gas. So essentially what's happening is, like, where's the energy, the heat energy going, like at this stage here. So if we think about what's happening, imagine in the solid, the particles are kind of packed closely together like so. So the heat energy, what it's doing is it's separating these out. Okay, so it's not increasing the temperature, it's just the energy is going into physically moving the particles that are in the solid further away from each other. Okay, and then so that's going from a solid to a liquid. Okay, and then so that's what's happening here, if you like. And then what will happen is once it's turned into a liquid, it will start absorbing the heat, so the temperature will start to go up. And then when it gets to a certain point, then what's happening is it's going from solid to liquid, and then from liquid to gas. So what's essentially happening is these particles are being pushed even further away from each other and making them more free to move around. So they're gonna be free to kind of move around. And again, what you have then is this period here of going from here to here. This is this heat that's been used. It's what's known as latent heat. Okay, and that's what's essentially happening during these periods here. So that's what's known as latent heat. So when heat changes a state, instead of the temperature, we call it latent heat. So the energy is being transferred into the moving the particles further away from each other and changing their state. If we think about then the body, for example, so in the human body, when we move around, we get very hot, our temperature goes up. So the role of perspiration then, so when we sweat, for example, what's the role of that in the body? When we exercise vigorously, we produce sweat. We perspire or sweat. This causes small droplets of liquid to form on our skin. Heat then leaves the body to evaporate this liquid or to change its state to a gas. So perspiration in the body's is the body's natural way at heating and cooling down. So unlike a human perspiration system, a dog's body cools itself mainly through an evaporation system that involves the dog's tongue. So although a dog's body does have sweat glands, the dog's body is cooled off mainly through its tongue. Dogs must never be left in a car on a sunny day because they can die very quickly from overheating. Okay, so dogs basically they cool down their body through their tongue. So again, what's happening here is this latent heat. So imagine this is the surface of your skin, for example. What will happen is when you get hot, you will get a liquid will form on the top of your skin. Okay, a bead of sweat. And what this does is it allows the heat in the body that's building up to be transferred into the water droplet. So remember that what will happen then is the water will be turned from a liquid into a gas. So this amount of energy, for example, will be transferred into the liquid sweat that's on your body, and then what will happen is that will turn into. So imagine then after a period of time. So what happens is that heat then is transferred in. So the bead of sweat, for example, that was on your body, it evaporates off the body, and then it takes with it that heat energy. So that heat energy will be turned into kinetic energy. And in that way, what happens is the body can stay cool. Okay, so the body temperature won't increase. Okay, if your body can't cool down, what will happen is your body temperature will increase, and that's very, very dangerous. And the same kind of principle happens on the dog's tongue as well. So essentially, heat is evaporated through the dog's tongue into the environment. So that's the role of perspiration. So that is heat, and we talked about the different way what heat is, how it's measured, the different ways that heat transfers through an environment, and then we talked about latent heat, and we talked about the role of perspiration then as well. Okay, thank you for listening.